Welcome to this lesson video. Today's lesson video we are focusing on empirical formula. Let us start. What is empirical formula? Empirical formula is the smallest ratio that represents a molecular formula. And then a molecular formula is an equation or formula that describes the combination of two or more elements. Also represents the number of atoms each element has in that mixture or chemical reaction. Let us simply jump to the examples. In most cases, this question will come in a manner of a scenario, sort of like, whereby they will tell you the composition of each element that forms a particular compound. Like, for example, this question, it's saying what is the empirical formula for a compound which contains 0.0134 grams of iron, 0.00769 grams of sulfur, and the last one is 0.0115 grams of oxygen. Now we need to calculate the empirical formula. Some of the questions, the masses will be given in terms of percentages. We have steps on how to calculate the empirical formula. Suppose you are given the masses in terms of percentage. The first step that you need to do, you need to convert percentage to grams. And then from grams, you calculate the number of moles for each element. After number of moles, you divide by the smallest number of moles amongst each element. Actually, you divide each and every element by the smallest number of moles within these three elements or more. And then from there, that is when you'll get your empirical formula. So let us start with this one. This one we don't need to focus on the first step, since you can see that our masses are in grams, so everything is fine. Now we need to calculate the number of moles of iron, number of moles of sulfur, number of moles of oxygen. So N is equals to M over M. N is equals to the mass in grams we are given, which is 0.0134. And then the molar mass, there is a lesson video on how to calculate the molar masses of compounds or elements. So the molar mass of iron is 56. Then let us go to sulfur, M over M. The mass is given as 0.00769 divided by sulfur is 32. N is equals to M over M. N is equals to 0.0115 over oxygen is 16. And then from here we need to simplify this fraction. Let me quickly punch the calculator. 0.0134 divided by 56. The answer should give you 2,4 times 10 to the power negative 4. mole. Then this one, so we have 0.00769 divided by 32. We have 2,4 times 10 to the power negative 4 mole. Then the last one, which is oxygen, 0.0115 divided by 16. The answer should give us 0.19 times 10 to the power negative 4 mole. Now we need to compare this number of moles. We can see that the smallest number of moles is 2.4 times 10 to the power negative 4. So we are going to divide each and every term by the smallest. Now we can see that for iron we have 1 mole. For this one also have 1 mole. And then let us quickly punch this onto the calculator. This one we have 3 mole. And then from here we can conclude to say our empirical formula is Fe, then this is our 1, and then we have sulfur, we also have 1, then we have oxygen, we have 3. So this is our empirical formula. Our second example, you can see that our masses are given in terms of percentage. Now the question is saying find the empirical formula for a compound which contains 32.8% chromium and 67.2% chlorine. Now how do we do this? 32.8% of chromium is the same as 32.8 grams of chromium. And then chlorine, we have 67.2 grams. So this is how we convert. We simply change the SI units. We have chromium, we have chlorine. Number of moles is equal to M over M. Number of moles is equal to M over M. Number of moles is equal to 32.8 divided by chromium is 52. Number of moles of chlorine, which is 67.2 grams over 35.5. Now let us quickly punch this. 32.8, 52. The answer should give you 0.631 mole. Then for this one, the answer should give you 1,893 mole. Then from there we can compare the two number of moles. We can see that the number of moles of chromium is the smallest. Then we divide. Then here we are going to have 1 mole. Then let us quickly divide this. This is 3 mole. Then we conclude that our empirical formula is CR. CR we have 1, and then CL we have 3. This is our empirical formula. Our next example is saying, what is the empirical formula of a compound which contains 67.1% of zinc and the rest is oxygen? So oxygen, initially we have to calculate it. It's saying we have 67.1% of zinc and the rest is oxygen. So how do you determine the percentage of oxygen? We know that the percentage of zinc plus the percentage of oxygen should give us 100%. Now, since we have the percentage composition of zinc plus oxygen percentage is equal to 100, then we can simply solve for this. We have 100% minus 67.1%. We have 32.9%. So we can simply write this. In oxygen we have 32.9%. From here we can calculate. We know that this is the same as 67.1 grams. This is the same as 32.9 grams. It's actually grams, not percentage. Then from here we can calculate number of moles is equal to M over M. Number of moles is equal to M over M. Number of moles is equal to 77.1 divided by zinc, it's 65. Number of moles is equal to 32.9 divided by 16. Let us quickly punch this. We have 2,056 mole, and then here we have 67.1 divided by 65. Answer should be 1,032 mole. We can see that the number of moles of zinc is the smallest, so we divide so here we have 1 mole. Then this side, let me quickly punch 2,056 divided by 1,032. The answer is 2 mole. So the empirical formula contains zinc and oxygen. Zinc is 1, oxygen is 2. This is our answer. Our next example, it's a bit challenging. It's saying 300 grams of an organic sample which contains only carbon, hydrogen and oxygen is analyzed and found to contain 145,946 grams of carbon, 24.3243 grams of hydrogen, and the rest is oxygen. So like the previous question, we need to work out the mass of oxygen. Now we know that the mass of carbon plus the mass of hydrogen plus the mass of oxygen, they sum up to 300 grams. So we have 145,946 plus 24,3243 plus oxygen, it should give us 300. Then solving for oxygen, we are going to have this plus this. The answer, we minus it from this. So oxygen, it's 129,730 grams. We have carbon, we have hydrogen, we have oxygen. The number of moles, m over m. Number of moles, m over, actually it's small m over big M. Number of moles, m over m. Number of moles, we have 145,946 divided by carbon, it's 12. Number of moles, we have 24,3243 all over. Hydrogen is actually 129,730 divided by oxygen is 16, and then punching this on the calculator, we have 12,1520 mole. And this one, we have anything divided by 1 is that anything, 3243 mole. Then we have 8,10813 mole. Then comparing this, we can see that the smallest is 8,10813, 8,10813, 8,10813. This side we have 1 mole. This one we have 3 mole. Then this one we have 1,50 mole. Now you need to be careful whenever you somehow get an answer like this, anything, 0.5, 1.5, 0.5. Don't round off to the nearest. What you need to do, you need to multiply each and every number of moles by 2. So we multiply by 2, we multiply by 2, we multiply by 2, and then we are going to have 3 moles. 1.5 multiplied by 2 is 3 moles, and then here we're going to have 6 mole, and then here we are going to have 2 mole. Then this will be the number of atoms which we have in our empirical formula. So we have 3, 6, and 2. This is our empirical formula. Now that's it for this lesson video. I hope it was very helpful. This is Bahula SJ. Thank you very much.